Okay, just let's see that predict an answer with a simple model here. Okay, let me take the example of the cost of the diamond. Here we have the carats and its price. First, you check the quality of the data. As I said, that it's a 4 question. One is it relevant or not? Yes, it is carats, and that is the price. So it is something like making a lot of sensible information. So data is relevant. Is your data is connected or not? Yes, it is. Every row has a full tuple, right? So definitely it has it is connected. And is it accurate or not? Yes, it is accurate. Unless until you see something like a huge outliers, or there are many outliers are sitting, unless until that. In the case of price, let us say that it is one is a 4-digit number, other one is a 10-digit number, one is a 1-digit number, or something like a negative to the power of 10 or something like that. If such data, then it is not accurate. Okay, but that's now it's looking at by just giving just a glance. It looks like the data is accurate. Is it enough or not? I hope it is enough. For my question, for this question is, the question is, how much will a 1.35 carat diamond cost? So in this case, all you need to do, you draw an XY axis. In X axis, you just put the carats, and then in the Y axis, you just mark for the price. Once that is done, you draw the scatter plot. In post of the scatter plot, you draw a Y with the help of linear regression or something like that. You draw the line which you don't require a model for here, linear regression. You draw the line which is closely the best fit you can do. Okay, just I think it is that we are doing it manually. And so you can just exactly at here between 1.34 here, and you just draw this vertical line and then the horizontal line, and you get somewhere close to 10,000. Okay, so 35, the carat diamond cost is how much? You can predict, even though there is no exactly the 1.35 is not available here. Okay, 1.31 is there, 1.53 is there, 1.51 is there. If you look at this data, is it now 1.35 is slightly, it's higher than 1.51. Yeah, there is obviously that there is a 1.51 is higher than the in the case of there is a, if you just look at this, it is not that particular wide. So that is the reason you get it is near close to the 10,000. That's why you need to do this a linear regression. Then you are not saying that it is a 1.35 carat diamond is exactly 10,000. You don't say it. It is approximately 10,000. So you draw a kind of an envelope which basically covering all the points, the maximum points. If you just, whichever not touching, think that it is a touching, then it is the only what the many points which is missing. So 1, 2, 3 or 4 points are just missing, maybe this. Okay, so remaining all the points, it falls inside that particular envelope. So within that envelope it is falling. This is called confidence interval. So the upper bound is basically somewhere around 12,000 and the lower bound is somewhere it is 8,000. So you are telling 1.35 carat diamond is going somewhere, the price going to be between 8,000 and 12,000, which makes more sense now. I'm not saying exactly it is 10,000, it is going to be somewhere 8,000 to 12,000. That's called the confidential interval. Okay. So what we achieved here, we could get an answer using the linear regression. We don't require a big mathematics of the computers. This we can take a paper, a graph sheet, and then you can do it. You can draw by, take a scale, and then you can put on a best fit of the line which is close to that. This can be achieved by manually, right? We've been doing it for many, many years. Yeah. But you think if this data is not just this 10 or 11 records, but instead of that it is a millions of records. And not only the millions of records, and think about that the features with the color of the diamond, the cuttings of the diamond, and etc. etc. Pardon? Yeah, adding more number of the features, what will happen? It's becoming so much complex. Okay, now it comes a multi-dimensional situation. So you can do it so easily on paper and pencil. Maybe to some extent mathematically, but beyond that, volume of the data when it is increased, you can't do it. It's definitely need a computer. Okay. So we have seen the 5 questions what you could ask the data science, and we asked the 4 questions to the data regarding the quality of the data. And I'm going to say that there's 3 things which you need to know about. There is a gap in the machine learning. So the gap 1 is basically nearly all machine learning algorithms assumes that world does not change. Yeah, something today. Let's say that you are just they're just finding a great algorithm and the great things of the self-driving car. Maybe self-driving car, it could be very successful. Maybe in US, maybe there's pretty much the roads as the conditions are very much they followed, that it is not so much abrupt, so it may go well. But on the other hand, if you just look at in Indian side, it may be a very difficult. Maybe after some point of time, let's say that 10 years from now, maybe that you think there is no cars at all, that everyone has own helicopter. Okay, which that helicopter has only kind of an air device, some device which just lift you, like a drones kind of stuff, which lift you and then put you up from point A to point B. The whole payload is only that your weight, and there is almost a negligible payload of the device. Okay, just the load is, the payload is only you. In such cases, you just think the gross weight is almost nothing except the payload. In such cases, you think that this may not be some of the algorithms which you just really finding it so difficult. It may not work, right? The world will change. And of course, world is always changes. Okay. The most machine learning algorithm, this is the gap number 2. The most machine learning algorithm takes a lot of example to learn. Say in something like in a global warming situation, you want to find some kind of information, you want to do a research and find it. But every year of the data, if you just summarize it, just giving only one data record. In such cases, what will happen? I have to wait for 20 years of data or maybe 30 years of data, just need to accumulate. Then I have to decide about that how this global warming is moving. But by the time that your algorithm is no use, right? Maybe in some other cases you just may get in case of the think about there is a terabytes of data been collected even in the 5 hours of flight journey. the huge volume of data is there. You can just do a kind of an anomaly detection, maintenance, preventive maintenance kind of stuff, or maybe some kind of information you can just get. You can ask some questions and you can get the answer from that. The huge amount of data is there. In some cases, when the data is not there and it will be arising, or you will get the data only in future. In such cases, this is a problem. Okay, you need a lot of data, because a human can just, if you just to your kid, or maybe that it is so much, nobody's teach you the grammar of, how many of you Telugu speaking here? Yeah, mostly. So, obviously you know that the grammar is not been taught to you in the childhood days, but still you speak grammatically. You instantly pick up that. But the machine cannot do that. To the machine you can just teach the millions and millions of record, and then it can do the learning. If I just say that this is a cat, this is a dog, the human can recognize it very quickly. Okay, just one time. You just see one tiger picture and then say that you just go to zoo, and then immediately you can identify that's a tiger. But that is not the case in machine. In the machine you have to give lot of data. So if that is not existing, then it's a problem. That's a gap. Okay. And the third one is machine learning cannot tell what caused what. It's a great example for there is a correlation versus causation. If you look at this data, there is no relation between the cheese eating and tangling with the bedsheet and getting died. But if you just look at this data, this is a real data. This is a very real data. So you can just visit that spurious correlations website. You can find a lot of interesting data. So this is the correlation. Because this is the pattern. No? This is what data science. Data science is all about finding the pattern. If you find there is a pattern, but there is no. But are you anyone believing that the bedsheet tying and the cheese eating is having some relation? Only not. There's a one more. This is the one which is US spending on the science and space technology versus correlated with the suicides happening. It's pretty much, it's a very cute, right? It is very correlated. It's almost 99% something like that. It looks like India Pakistan batting. When you just draw, it is almost sometimes goes neck to neck same. Even that will have, most of the time it will have a lot of differentiation, but here it is not. The third one. So what is any relation of between the diverse and margarine? And there is a few more interesting thing. You can just there is a data about the Nicolas Cage movie release versus number of people dying in the swimming pool. No relation, but there's a beautiful the correlation which has been shown. Okay. So how do you close the gap, such kind of gap? You can bridge that gap. The human insight and judgment close the gap. Okay. Because we are so good just by giving a very few little data, we can guess what it is. But in case of if you take the system, you have bound to give the huge volume of data. But for a human, you can just guess most of the stuff which by with a little amount of data. So even without enough information also we can guess. We are good predictor. Okay. So there is three types of machine learning in broadly. One is a supervised Other one is the unsupervised. The one more is the reinforcement. Okay. I also ask you to look at the sum of the resources. How many of you know the Kegel? How many of you know Kedi nuggets? Using this. This one, third one, Cortana, gallery. Anyone? Anyone visited here using the solving the puzzle? Yeah, Microsoft Azure. So this is the Microsoft Azure one. So there also you are having a lot of valuable information. You can just pick that. Okay. Okay, we come to the final stage. I want to ask you, there's a recap. What are the 5 questions data science can answer? Just I really want to answer it. Could anyone from here can just raise your hand? 5 questions. At least one. What do you remember? What are the 5 questions you can ask to data science? Is it weird? Classification question. Is it A or B? Regression question. How many or how much? Reinforcement is what's next? 3 questions here. Is it A or B? That's a classification. The second one is it weird? Anomaly detection. And third one is how much or how many, which is regression. And the fourth one is how it is organized. So which is basically clustering. And the fifth one, reinforcement. What is next? Okay.